Hello friends, this is your coach Vinay and you are watching Science Thesis for you. So in this video, I am going to teach you how to select SN1, SN2, even E2 reactions. Well, nationwide, there is a lot of confusion among students when it comes on selection. I hope in this video, I am going to solve all your doubts, all your problems. Better you should watch till the end. So let's begin. Alright, before going further, I have assumed you know SN1, SN2, even E2 reactions. I mean the basic part. If you already knew, you are in business. First, we're gonna learn all these reactions on substrate like alkyl halide and alcohols. These are the most common one. Second, when it comes to selection, there are no written rules in any of the book which clearly state the selection criteria. So what we going to do? Well, I have a solution. We have factors which we will follow, and in the end we will be having a clear idea about the selection. Here are the factors on which all four reactions gonna depend. First is the substrate, second nucleophile slash base, third is a solvent, and fourth one is a temperature. We're going to study them in detail. But before starting with the first point, I want you to remember a few things. Even an SN1 reaction highly influenced by carbocation stability. If the carbocation stability is high, the chances of even an SN1 is high. Second, SN2 mechanism is clearly influenced by the steric hindrance. If there is a steric hindrance in the molecule, SN2 chances will going to decrease. But for E2, there is no such things. Now let's talk about first substrate. Alkyl halide and alcohols, they both can be considered as a substrate over here. I am taking alkyl halide as a substrate. So here I have taken all three alkyl halides, 1 degree primary, 2nd degree, 2 degree and tertiary 3 degree. Let's suppose you have 1 degree alkyl halide. So now even an SN1 reaction we will not prefer here in this case. Why? Because if you see Br, if it leaves, it bring the 1 degree carbocation, that is primary carbocation, which is not at all famous or it is not feasible in our case. Okay, so other two SN2 and E2 you can prefer. They are in business. Here 2 degree alkyl halide all are in business. There is no restriction at all. But if we have 3 degree alkyl halide, here in this case SN2 mechanism, we will be having the preference at the lowest level. Why? Because you see the CH3, CH3, CH3. All CH3 groups are creating the steric hindrance. And in this case, if nucleophile going to attack from the back, it will be having the huge steric hindrance. So SN2 reactions, the preference rate is very, very low. Other three, they are in business. Here, it's a note. You see these alkyl halides, substrate, which falls in the category alkynyl and alkanyl halides. There's a problem with these kinds of substrates. That is why we will not going to take these substrate in our all these reactions, SN1, SN2 and even E2. The problem is the Cl is in the resonance pi sigma lone pair and it will not going to easily come out from the molecule. Same thing problem arising with these molecules also. So keep this thing in mind. Second factor is nucleophile and base. So you see, if you see somewhere the charge or strong nucleophile slash base, then you should cut it the possibility of even an SN1 mechanism. The chances is very, very low. Why? Because even an SN1, they go through the carbocation mechanism and it need time to relax, to slow things little bit down and then do performance. Why? They are strong, they will not wait. They always look for one-step mechanism. So that is why I've cut it there down. But the E2 and SN2, they are in business. Why? If you see here the neutral or weak nucleophile slash base, then the chances of E2 and SN2 is very, very less, is very, very low. Why? The reason is they are weak. They are weak. So they will not going to perform the reaction in one step which E2 and SN2 require. So they have cutted them out. So the chances of E1 and SN1, they people are in business. Important note, guys, if you are taking bulky base slash nucleophile, then okay, first let's talk about what is base and nucleophile. You might be thinking what the difference between them. Okay, a species can be acting as a base as well as nucleophile. Suppose a species, if it is going to attack on hydrogen and take the hydrogen back, it's a base. And if it is attacking on an electrophile, then it is a nucleophile. So the same species can do both the tasks according to the situation. So here I'm talking about and stressing on bulky base. The reason being because if you are taking bulky base, then the E2 mechanism will going to prefer because it is easy to get the small hydrogen back and acting as a base rather to act as a nucleophile to attack on electrophile, and there would be some kind of a steric hindrance. So therefore, the example of bulky base is the most important one. Here it is T for tertiary butyl oxide. There are a lot of more examples you should remember. The examples are DBN, DBU. It is DIPE, I call it, but it is DIPEA. And the last one is LTA. These are the most important used bulky base in exams. Third point, solvents. Generally, we talks about two types of solvent. First, the polar protic solvent. Here in this picture, you can see few examples of them. Examples like H2O, alcohol, etc. you can see. They generally give H positive and they do involve in hydrogen bonding. The other type is polar aprotic solvent. Here in this picture, you can see few examples of them. The examples like acetone, DMSO, etc. Well, what is the point? The point is you see PPS, polar protic solvent. If you are going to use these examples of these solvents, then E2 elimination will prefer rather than SN2. Well, the idea behind this is when you are using polar protic solvent, it will surround your substrate as well as the base, right? And polar aprotic solvent, they don't have the ability to surround the substrate or your base or nucleophile. So when it is surrounding your nucleophile or base, so it will be bulky and it will act as a base rather than nucleophile, and it will perform E2 elimination than SN2. The opposite is happening over here. Here it will not surround your nucleophile, hence SN2 will prefer rather than E2. You can also see I'm using the base in elimination and nucleophile in substitution. Well, here is the last point, fourth point, the temperature. At low temperature, we'll prefer SN1, SN2, I mean the substitution reaction. And at high temperature, we'll perform the E1 and E2 reaction. Keep this thing in mind. Alright guys, we have finished all the four factors, and out of all the four, the first two were the most important one. The substrate and the nucleophile slash base. The other two are not that much frequently going to use in the reaction. So let's talk about some examples where we apply all these things that we have learned. Here are the examples to learn. So the first one is 1 degree alkyl halide, and you see here I have taken nucleophile slash base is a strong one. So can you recall what we have studied? 1 degree alkyl halide, it means you can apply SN2 and E2. Even in the SN1, chances are no more valid over here. So SN2 and E2 we can apply, and it is 1 degree So I'm going to prefer the SN2 mechanism over here, SN2. The reason is steric hindrance. 1 degree, there is no steric hindrance, so SN2 will be having a little bit dominance over the the product. So here I got both the product. This is from E2 and this is from SN2. This is a major product. Now this is the point to remember. 1 degree alkyl halide, if the base slash nucleophile is strong, then SN2 mechanism will prefer over the E2 mechanism. Now the second point. Now I've changed the alkyl halide. Here it is 2 degree alkyl halide. Come on guys, you can also answer. You can pause the video and you can think about this. Now I'm going ahead. So 2 degree alkyl halide. Now again the base slash nucleophile I have taken here, the strong one, ETO minus. This is ethanoate ion. So you can see the 2 degree alkyl halide. All four reactions are valid, but if I see this is a strong one, so even an SN1 I will not prefer. So now again I have to fight for E2 and SN2. Now this is a 2 degree alkyl halide, and there would be a kind of a steric hindrance. So I will not prefer SN2. I will prefer E2 over SN2. Here also I got both the product. This is elimination product. This is substitution product. SN2, E2. But the answer, the major one is E2. Here again, you should learn all these things, guys. It is quite interesting. Here, if I have taken 2 degree alkyl halide, steric hindrance comes in the picture, and the SN2 is now no more the dominant product. The E2 is the dominant product. Here, the third example, alkyl halide I have taken, and here also I have taken nucleophile slash base is a strong one. Now you can see 3 degree alkyl halides. What we have studied, just recall, on 3 degree alkyl halide, we will not go for SN2 mechanism because steric hindrance is there. So now we have three options: is SN1, E1, E2. Now it is a strong one, so we have to go with E2 elimination. Alright, so here again we got two product. This is basically the major product, and here we are going through the E2 elimination, and of course little bit substitution will also going to take place here because this is occurring at very low temperature, and at low temperature this product what we are getting is the SN1 product, right? And I want to tell you one more important thing that you should note. When there is a chances of elimination and you have to make a call between E1 and E2, always go for E2. This is my opinion for you all people, because elimination E2 is always preferred rather than even. The reason is even has to fight with SN1. Both are going through the same path. The first step, carbocation. So even an SN1 they're going to fight, and hence the E2 will get edge over them. So now we see the fourth question, 3 degree alkyl halide. What I have changed here, the temperature. I have increased the temperature. Now the temperature is high. Same, the nucleophile slash base is strong and 3 degree. SN2 no chance. And if you increase the temperature, it means there would be no substitution. So whatever the product you are getting is just the elimination product, right? Again I'm writing over here is the E2. As I suggested, there would be E1 and E2 in this, but E2 I am taking that as a dominant one because E1 has to fight with SN1 sometimes, right? So the fifth example, interesting one, 3 degree alkyl halide I have taken. Now I have changed the nucleophile slash base. Again, you are understanding why I am again and again saying the nucleophile slash base. If it's an elimination, I'll change change that thing to as a base, and if it is substitution, I'll consider that as a nucleophile. Right. So here it is. It's a weak one, and there it is an alkyl halide. Now you can think it is a weak and low temperature. Weak, so SN1 and E1 are the priorities, and it is low temperature. So again, the SN1 is the major product because substitution occur at low temperature. And here also we got two products. This is elimination, but that is a minor product, and this is the major product. I hope you understood these examples. Let's take few more examples. Here's the sixth example. We'll see 2-degree alkyl halides I have taken, and here it is a nucleophile slash base is a strong one, CH3O minus. So it gives you the option of SN2 and E2. And heating is here. You can pause the video and think. So heating is there. I'll prefer elimination over substitution. So I'm going to go for E2. Alright, E2, so the bond will be there. This is the major product that I have drawn. So elimination occur. The seventh example, alkyl halide is 3-degree alkyl halide, and the nucleophile slash base, actually it is a base, and the strong one, again I have two options, SN2 and E2. Now you recall through your memory, and just look, this is a 3-degree alkyl halide. SN2 will not going to perform over here due to steric hindrance, and hence again we will get the E2 elimination. E2 elimination because of the strong base over here. Now, one more important topic you should understand is the dehydration of alcohol, and it is basically the elimination reaction. And here we have three alcohols: 1 degree, 2 degree, 3 degree, and you have to remember this very important, that 1 degree alcohol always prefer to go through E2 elimination, and the rest 2 degree and 3 degree they will prefer even elimination. They will form carbocation and rearrange themselves, and according to that they will be have the elimination. I hope you got the idea about how to select the reaction and when. Just do one thing, make a note of it and keep practicing. And one more thing, if you like the video, then do subscribe my channel. And if you want to say something, please comment me, and I'll be waiting for your comments. Thank you.